Hello everyone, I am Sarwar Hussain Paplu, a PhD student at Robotic Research Lab, TU Kaiserslautern, Germany. Today I am going to present our paper titled Pseudo-Randomization in Automating Robot Behavior During Human-Robot Interaction. The main contents of this presentation include an overview of the psychological backgrounds in the context of behavioral variability and its relevance for social robots. This will be followed by a relevant literature survey in human-robot interaction. There will be a short description of the robot and the framework that we used. Then I will explain the implementation of a system that can, under some conditions, automate the robot's behavior during interaction. After that, the results from experimental scenarios will be discussed. And finally, the presentation will end with some concluding remarks. So speaking of the psychological background, a human perceptual system or human perceptual process starts with a mental representation of a stimulus. And then this stimulus triggers a response in the process. However, there are some important factors influencing the interpretation of the stimulus. The factors might be, for example, prior experience, expectations, or desires, self-concept, or even perceptual constancy. Though change in behavior is highly controlled by stimulus or stimuli response laws, humans tend to show differences in behavioral pattern even if we perceive the same stimuli. So it's very interesting to notice that there are no fixed rules as to how and why humans or we react differently to a fixed stimuli at different time steps. Now let's discuss the motivation of this work. Our existing robotic system can interact in strict rule-specific or stimulus-specific scenarios, but this often comes with some problems. For example, the system can't offer more options for possible behavior. Therefore, there is a need for selection of appropriate gestures and expressions in order to make HRI much more engaging and, of course, more natural. Before implementing a desired system, we looked into some relevant literary works. The works conducted by Ekman and Friesen offered an insight into how human facial expressions are generated. They offered a coding system, which is known as facial action coding system, based on the action units. The action units are the fundamental actions of individual facial muscles to represent a particular emotion. In the book Body Talk, there is a compilation of a huge set of everyday gestures. They are universal in nature, and there are also illustrations, meaning, action, background, and the locality of each gesture. We also researched some other works related to this. For example, this one, Bodily Expressive Action Stimulus, or BEAST. In this work, A total of 254 images or body images were captured with faces obscured. And then 46 professional actors were asked to make these gestures. Then 4 basic emotions, namely fear, anger, happiness, sadness, were leveled to each move. There are also other works in the literature that deals with learning of gesture, and the approaches are mostly vision-based and imitation-based. The last work that we also found really interesting was the implementation of hardware-implemented gestures with lever notation. Coming to the robotic framework that we used. This is, as you can see here, this is our robot, which is a life-sized humanoid robot called Robin. It has a total of 34 degrees of freedom in the entire body, as you can see here in the hand, the shoulder, and even the torso. So altogether we have 34 degrees of freedom. And there is a backlit projected phase here, which also has a relation to action units. The ASUS Xtrion camera here, the RGB and depth sensor, is mounted on the chest of the robot, and this is our main perception system. Also, we are using, for the implementation of our system, we use a framework which is called FinRob, written in C++. First, the process starts with the implementation of gestures. A set of unique gestures were implemented by controlling the joints of the robot. The type of gestures implemented include static gesture, it can be a dynamic gesture, cyclic, or trajectory. A static gesture simply reaches a specified set of joint values, whereas there is a specified pathway. It's not necessary, but for trajectory-based gestures, we need to specify a specific pathway for the gesture to perform. And then we group each of the gesture into some emotional state or emotion grouping, I would say. For example, some gestures will fall under anger, some will fall under, for example, happiness. And then we ensure a transition between the gestures, because this is also important. We have to make a smoother transition between two subsequent gestures. And now talking about the implementation of facial expressions. We combine the action units available on the face of our robot. And then we activate relevant action units to make a relevant or meaningful facial expression. And this work was highly motivated by the work from Ekman and Friesen that I have already introduced in the literature survey. So we combine the action units, and based on the intensity value of the action units, the expressions may a little bit change their meaning. For example, here we can have a weak versus a strong activation of AUs, which will indicate probably a slight versus a strong disgust. So there is possible that we can implement slight gesture, or we can also slight disgust, or also we can implement strong disgust on the face of the robot. Instances of happiness here, for example, we have 3 instances. We are calling it pleasant, this one is laughed aloud, and this is teasing smile, but they all fall under happy emotion group. So similarly, we have implemented other facial expressions which fall under other relevant So now I would like to talk about the workflow, or which is the main part of of this work. So the process starts with a dialogue. From a dialogue file, we start the dialogue, and when it starts, when the dialogue starts, the robot, we set a robot emotional state, yeah, based on the activity of the interaction partner. So the emotional state can be robot state, or robot's emotional state can be the 6 basic emotions. For example, happiness, sadness, fear, anger, disgust, surprise, etc. Then we jump to a module which is called automate gesture or expression module. That automates the gestures. Mostly this module is responsible for the automation of gesture and facial expressions. But in some situations, we directly go from the dialog file, we directly go to this module instead of setting a robot state. But there are some situations, I will explain it later. So there is a random function here in this module, which calls the random function and selects an appropriate behavior from a possible set of behaviors or actions, which are our, of course, pre-implemented gestures and facial expressions. And this is the place where the pseudo-randomization takes into place. In other words, we select an action or we select a behavior from a pool of predefined actions or behaviors. So that's why we call it pseudo-randomization, because we don't random anything, rather we give a restriction. We tell the system that we have 8 gestures, so now select one from the pool of gestures, or similarly for facial expressions. Then the robot performs the action which is called by this module, and then again the dialog control goes back to the dialog file, and then again the same process repeats over time. And this process goes on until we come to an end of the dialog file, or the control flow goes to the end, and then the interaction stops. Okay, then now let's talk about a little bit about the experimental scenarios. The system was tested on, of course, many situations and scenarios. For example, in this scenario, the robot is aware of, the robot is aware of interaction partner's proximity. The robot changes its emotional state based on the proximity related activity of the partner. So we have set various proximity zones, as you can see here: social zone, public zone, personal zone. And if the person encroaches, for example, the intimate zone of the robot might get angry. And based on this is an activity from the interaction partner, and the robot will change the emotional state, and it might get angry, and because of getting angry, there might be the relevant gesture and facial expressions comes out automatically. So in this scenario we tested this, and then again we tested in the greeting scenario, in which the interaction partner stands in front of the robot greets the interaction partner, and of course wants or expects a greeting back. But if the interaction partner does not give greet, the robot in some situations get sad and expresses emotion out of it. Whether or not the person has greeted the robot back is detected by the body recognition of hand gestures or body postures. So in this way we ensures that the robot changes its behavior, but not the same kind of sadness every time. So we have pre-implemented sadness. So one instance from the pool of sadness behavior will just pop up, and the robot will execute this. Then we, in fact, as a matter of fact, we definitely have to test our system and have to see how it is observed from a human-centered point of view. So we invited 20 university students, and most of them are, of course, diverse, coming from diverse nationalities, and they took part more than once in the interaction process. And then we asked them a lot of some questions with regards to the emotion, with regards to the ability of the robot to express, with regard to the context appropriateness. And as you can see here, we noticed that there was a rating of 4.5 in terms of happiness, and whether or not the robot understood the context appropriateness. So there was also a rating of 4.8 in which people agreed that the robot was able to express anger. So the scaling was from 0 to 5. It was a Likert scale, and yeah, so this was a high score for the case that the robot expressed anger. And this is just an overall rating of the behavior of the robot. Yeah. So people observed the behavior and they rated in terms of change in behavior, 3.7 out of 5, and whether or not the robot behaved like a human, it was more or less like 3.8, score of 3.8 out of 5. Yeah. So this was all human-centered evaluation. So to conclude, we have presented a pseudo-randomization approach in the selection of robot actions, to ensure better human-robot interaction. Interestingly, in this case, our perception system was highly dominated by non-verbal cues. So it was, in some cases, the recognition process, if the recognition process doesn't perform well, then the system behaves not as expected as we want. So integration of vocal cues can help us in this regard. So this can be a possible future work to improve the system, and also if we can appraise or evaluate emotion in the real time, then there is a high chance that the system would perform much better, and to ensure, of course, natural human-robot interaction. So thank you very much for your attention. So if you have any questions, please feel free to ask me.